This is the video record for probability and stochastic process homework for problem 2. The problem setting is given a random variable x, it is uniform on the interval of from -1 to 1, and we need to find out the gx or g of x such that if y is equal to g of x, then the density function of y is equal to e to the degree of -1 times the u of y, where u is a uniform function. And since we know x is uniform on the interval from -1 to 1, the distribution function of x should be the area of this part where we take g of x is follows a certain gradient, and the value of distribution function should be the area of this shaded area, which is a triangle. And also since the density function of y is equal to e to the degree of -y times u of y, and we can try to calculate how the distribution function for this function is equal to y minus 1 minus e to the degree of -1. And we need these two distribution functions to be the same, which is actually the fx, the density function of the distribution function of x, which is capital letter fx of x. It's equal to x plus 1 over 2. It's also equal to the distribution of y, which is capital Fy of y, equal to 1 to the degree 1 minus e to the degree of -y. And we try to solve this equation. We get the value of y is exactly equal to minus ln 1 minus x over 2, which is exactly equal to g of x. And so this is the desired g of x we are trying to find. And also we discuss the different values when g of x is equal to 0 and g of x is equal to infinity, because when x is less than -1, this value can the value of g of x must be 0, and when x is larger than or equal to 1, the value of g of x is equal to infinity, which is not when g of x is equal to be this value, this is only valid when x is between -1 and 1. And so to discuss more about this question, I guess the point is that we need to find out the distribution function of fx, and to find the distribution of fx, as we know, it should be not only but it should be when the distribution function is to be found given a certain density function, and it is uniform, we'll get that the distribution function is exactly the first and the second, the starting point and the ending point of this uniform interval area. That is to say, when we try to find out fx of x, it is actually equal to the part where we are started in the first starting point of -1, and we're trying to reach the point at x, and we need to actually the value is supposed to be x minus -1 over 2, where 2 is exactly the magnitude of this interval, which is from -1 to 1, and this is by definition is the distribution function for a uniform density function. So that is how we get the value to be here, and such that we can calculate out the value of the function g of x. This is the end of this question, problem 2.